I'm pleased to introduce two speakers for this session, Bernardo Mendez and Chris Langel. Bernardo is the Director of Solutions Engineering in the US for Rescale, responsible for technical pre-sales. Born and raised in Mexico City, he has spent nearly 15 years working with CAE applications and helping engineers leverage HPC and cloud services to tackle complex simulation challenges. Bernardo holds a master's degree in computer manufacturing with a background in mechatronics. Before joining Rescale, Bernardo had a major focus on the automotive industry, first as a chassis development engineer and later as a technical specialist in hardware in the loop systems and multi-body dynamics applications. Chris is an HPC engineering manager at Rescale. Prior to joining Rescale, Chris worked as an R&D engineer in blade aerodynamics for Siemens Gamesa. He has a bachelor's in mechanical engineering from the University of California, Berkeley, a master's in mechanical and aerospace engineering from the University of California, Davis, and a PhD in mechanical aerospace engineering, also from the University of California, Davis. It will now be our pleasure to hear from Bernardo Mendez and Chris Langel.
Hello to all of our virtual attendees, and welcome to this next session where we're going to be exploring some of the work that we've been doing around performance intelligence and some other general discussions around how to get the most value when running HPC workloads in the cloud. My name is Chris Langel. I am an HPC engineering manager here at Rescale. The team that I lead primarily focuses on performance optimization for different software, running these different software on all the hardware configurations and architectures that you're going to find in the cloud. Recently, we've been doing a lot of development work on an AI-driven compute recommendation engine that the team is very excited about, and definitely going to talk more about that as this session progresses today. So a theme that we've seen at this event has been sort of this fragmentation of compute and emergence of numerous specialized architectures, how things that were not particularly relevant to the HPC community maybe 15 years ago are suddenly very relevant, such as ARM chips or GPU nodes that now make up some of the world's largest supercomputers. We don't really live in a world where you can tell everything you need to know about the performance of a hardware configuration simply by looking at the clock speed on the chip. There's a lot of different competing factors that go into it these days, and often those factors can compete against each other, such as the CPU density on the chip has to be balanced with the memory bandwidth. Otherwise, you may find yourself in a situation where you have too many processes or MPI ranks trying to access the same memory address, and ultimately slowing your simulation down. We're seeing some of the world's largest CFD software companies port their codes over to GPUs. We've done some benchmarks on these for certain models and have seen very fantastic performance. This is something we're very excited about, and something that we look forward to seeing evolving in the not so distant future. And then a lot of people these days are thinking about sustainability. They're thinking about the environment. They're thinking about their carbon footprint, and they're very aware that running simulations is ultimately consuming energy, and making these decisions around, okay, if this particular hardware configuration runs my software 10% faster, but it takes 10 times the amount of energy, maybe that is not the right hardware configuration for the job. Maybe that's not the right one that I want to be using. And so, in this modern era, HP or IT managers really need to kind of think about all these different factors when they're deciding, what type of hardware they want to put in their on-premise cluster, what type of instance, what type of node they want to get if they're looking at a cloud-based service, and really just kind of combining all of the different competing factors together to ultimately make the decision about what type of hardware they want to make available for their engineers. And then there's this additional factor where specialized hardware can be incredibly effective. It can be incredibly efficient when applied to the right problem. However, if you apply a certain specialized hardware to the wrong problem, the opposite can happen, and you can ultimately end up costing yourself a lot of money because you're running something that really wasn't meant to be run on that particular configuration. So also, not only is the hardware getting more diverse, we're seeing in a modern engineering design cycle, there's all sorts of different tools that are applied to various components of the product. For example, an electric vehicle company may be using a CFD tool to analyze the aerodynamics of the exterior of the car. They may be using some FEA tool to analyze the frame and the body components. They may be using some thermal analysis tool to better understand the heat dissipation around the battery. And all of these different tools are modeling different types of physics. That physics is governed by different equations, and ultimately those equations are discretized using different methods. And sort of a consequence of that is different discretization schemes lend themselves better to different types of hardware. For example, some are incredibly well suited for a GPU accelerator. Some scale really well, like you can just apply infinite numbers of nodes and they'll just keep scaling. Some not so much. And so what this ultimately comes down to is when deciding, okay, what is the best hardware configuration? The answer is there's really no one, because it depends a lot on the tool that you're using and the model that you're kind of developing. And so this is where we kind of start to see an even bigger appeal of moving to a cloud-based solution where you can kind of mix and match these different hardware to the different types of models, the different types of jobs that you may be running. Now, this is where you also need to make the decision which hardware needs to be paired with which software. Of course, the brute force method of doing this is to just run all the different tools, all the different software, on all the different hardware options. This, of course, is not terribly practical. It's incredibly expensive and time consuming. And, I don't think that many people would consider this a great idea. And so, it'd be really nice if there was, some type of tool or some type of service, to help you make these sort of pairings. And so kind of with that in mind, we see that the cloud does become a little bit overwhelming. When you're trying to say, okay, I want to optimize my workloads. I want to optimize like what I'm running in order to kind of make it cost effective to run in the cloud. But, in doing so, like it's, very expensive to make those decisions because I have to, run all these different configurations to decide and ultimately land on, the one that is, the most effective for my particular use case. So as we can see, this again is why the company Rescale has put some emphasis on, this performance intelligence idea that, we want to help you guys and, other engineers make these decisions to kind of navigate through this like increasingly complex landscape and, help people land on the most efficient, the most sort of optimal, hardware for their type of problem. Yeah, stepping back a little bit and thinking about just like, this idea of performance in general, one of the biggest challenges is that it's inherently relative, right? We can't just look at a single point in space. We can't just run a single problem on a single hardware configuration and say, this hardware configuration is running this really well. Unless we, of course, have a bunch of data points around it to sort of better contextualize it. You can't just kind of arbitrarily pick a point in space and, infer much about, ultimately how efficiently that workload is running. Now, Rescale has done, extensive testing on, our hardware catalog. We've done a lot of testing on, different software, different hardware configurations, and, we have thousands and thousands of data points, and so, we've done a lot of thinking about how do we kind of best utilize this data? How do we best utilize our experience? How do we best utilize, this historical things that we have done and, use those to provide value to the people that want to use the platform, that want to use some of these features. And so, at a high level, we can start thinking like, okay, we can start seeing trends in the data. We can start kind of pointing people to, subsets of the hardware catalog, subsets of, the hardware configurations that you're going to find and say, certain classes of workloads are going to perform well, with this particular type of hardware. However, it gets a little bit difficult to kind of, hone in specifically. We can sort of kind of find the general vicinity of where you should be at, but, getting to the point where we can kind of pinpoint what is actually happening with your model and, what is causing it to perform well or not well on a particular hardware configuration has proven to be a little bit, challenging. And so this is kind of where this idea of compute recommendation engine starts to come into play and, to sort of hone in on specifics and to try to, take all this data that we have. What we really want to do is, use all of the data we've collected and somehow leverage sort of deep learning, other types of machine learning techniques to better extract and understand, how your particular, model, how your particular job is doing, and how well it is sort of utilizing the resources. At a high level, the premise of the methodology is that you can find a source of truth in hardware utilization metrics. The hardware, the set of nodes, they don't really care what application you're running. We don't care what your model is. They don't care if it's a plane, a train, or an automobile. What the hardware does care about is, how are the resources being utilized? Are all the CPUs being, saturated? Is there, sufficient memory access for the different processes? Is there a ton of traffic over the network? All of these different things can ultimately tell, how that, software will ultimately perform on that hardware. And so, we've taken all of this data that we have and started tagging it, we started conditioning it, and we started saying, hey, let's try to use deep learning to take all of this data that we've tagged and try to detect patterns in sort of the hardware metrics that can then be mapped to, actionable recommendations. And so, the model that we've been developing is a combination of, heuristic filters that we've taken, many of our kind of own experience and applied those to sort of the time series, and then sent those into a variety of different time series classifiers and kind of put the whole set together to create this kind of recommendation system that can take a particular job, and then it can try to send it through the recommendation system and understand what type of hardware is going to run that job well, sort of based on the thousands of data points that have been tagged and kind of injected into this model. And then ultimately to the end user, they'll understand, okay, is my job running efficiently? Is there a better option? And we want to present that to them. I like to kind of think about it as that we are really kind of embedding decades of experience and all of this data that we have into this AI model that ultimately gives users feedback and specific feedback to their particular workload, and how to better utilize the different hardware options that they have available to them. And this also allows for this kind of continuous optimization cycle. As new hardware comes out, and we kind of use that in the training cycles. The model will then kind of pick up on what models that are running will well suited for this new hardware. And so there's definitely some implications of this that I believe that Bernardo is going to be kind of discussing as we kind of hand off to him. Thank you, everybody.
Hi, thank you for being here today as we continue to explore how Rescale leverage an AI-driven performance engine to provide automatic and tailored hardware recommendations that will optimize the use of HPC towards your business goals. My name is Bernardo Mendez, and I'm a Director of Solutions Engineering here at Rescale. My team includes industry and application specialists that work closely with engineers and IT admins to help them get the most value within their cloud journey. So, what are some of the things that we can do with this AI performance-driven engine? Well, to start with, we can identify what are those bottlenecks for performance. Is it being limited by the CPU load? Perhaps it's the memory, or even the network bandwidth. By knowing what is the limiting factor, we can provide now a tailored recommendation down to the individual job to maximize its efficiency. We also can recognize opportunities for scalability. By knowing that the network bandwidth is being stressed out and looking at a low CPU workload, we can find that the problem is likely over-parallelized as it's spending most of its time communicating between processes. Finally, we're future-proofing your use cases, because once you know what those limiting factors are, when new hardware becomes available, you can simply look for those characteristics on the hardware that becomes available and leverage it for that same type of problems. Now, for your business, we know that customers may have different goals that are shifting project to project as they reach their milestones. In some cases, It could be minimizing the overall cost of simulation, which it will be reflected in the overall cost for development. In other cases, it could be making sure that we meet that key milestone, that deadline, and we want to make sure that the time to solution is the shortest regardless of cost. Or in other cases, it would be best to leverage both. The best value translated into cost performance. By giving customers the flexibility to dynamically choose the proper hardware, giving the goals that the business is focused, we've seen that they can obtain up to 40% of efficiencies, 50% of cost reduction, or 50% of performance increases. At the pace of technology advances and identifying the proper hardware each time you go and submit a job, you are effectively making sure that you always have the right choice to maximize its value. But well, what does this all look like inside the Rescale platform? And it's comprised by 4 key features that we are unveiling: performance profiles, performance dashboards, performance optimization, and our compute recommendation. Let's take a look at each of them. First, performance profiles, which it simply is an interface for the users that will allow them to run in-depth benchmark analysis directly in a single plane. How they do this? Well, they can start from a job that they have already run on Rescale or a template configuration that defines a specific type of problem. They can then easily select from a list of all the different hardware options where this application is readily available and pick different core counts to run their study. Rescale will then automatically run this whole benchmark, coming back with specific runtimes and costs for each of the jobs. It will also provide a plot that then can easily visualize what is the best hardware given the metrics that the user is looking for. Again, is it cost? Is it runtime? Or both? And they can also share this information with other users or other teams in order to collaborate on this analysis and share best practices towards a type of problem. The next one is for our IT admins, performance dashboards, giving them a single place where they can look at the entire consumption and, more important, the cost, the impact that they have, not only for hardware, but of course for software, which in many cases we know that it represents a higher cost than the hardware due to the licensing. Now, this is key because even though there could be cases in which customers are hosting their licenses on-prem, they can input the cost of those licenses straight into the interface to make sure that they're part of the calculation. Then, with a single click of a button, they can move to a performance optimization, where Rescale, because of our knowledge of the specific application and of course our AI-driven engine, we can then offer suggestions that will optimize either performance, cost, or both. So in this case, the admin can simply look at the different comparisons, at the different options that are available to them, and with a click of a button, implement a policy that will be rolled out for this application for their users, making sure that the next time that they go and run this type of problem, they're picking the hardware recommended by their admin. And finally, the core type recommendation, or our compute recommendation, making it easy for the users when they're going and setting up a new job through the interface, having specific options that are already provided, again, to highlight toward these 3 key metrics. And very easily, they can choose whether they want to optimize for cost, for performance, or value, and pick the hardware that has already been vetted towards this goal. Now, please reach out to us. We want to help you. We want to understand what you're optimizing and maximizing you and share that journey with you. Our team of experts is looking forward to do that. Thank you.